Hello and welcome to the Pharmacy Informatics Professor 2020 with your host, Dr. Armin Simonian. Whenever I teach a pharmacy informatics course on day one of class, I like to go through a digital magic exercise. I play a little magic using some cards, and I am able to have the students think of a number between 1 and 63. And on a sheet of paper that has a display of 6 cards, I have them cross out the cards that does not contain their number. And then at the end, I can look at their 6 cards and see which ones they've crossed out. And I can guess their number with 100% accuracy. Today, what I want to do is have some fun and go through this exercise with you and see if you can go along with me and guess my number that I'm going to have in my head. And then we can talk about how this magic works behind the scenes. And then take a step further and see if we can actually write a computer program that would do the same thing. So let's have some fun. Let's get into it. And I will share my screen and we can look at this presentation on digital magic. So Pharmacy Informatics Digital Magic, and here's the exercise. I will think like a computer and guess your number with 100% accuracy. And I tell my students that this little graphic here is the whole key to the exercise. So if you understand what this is, and this is actually a little circuit that you would find in any computer chip. And if you can think like a computer, you can guess a number. So I've picked a number in my head between 1 and 63. And we're going to look at the playing cards now, and we're going to see if we can guess that number together. Okay. So here are the first 2 cards. And I'm going to look on these cards and see if my number is there. And I see that it is on the first card, but it's not on the second card. So what I could do, and let me see if this works, is go ahead and cross, ooh, that's a wavy line, cross this card, all right? So now I'm gonna go on to the next set of cards. Let me go back. So I'll tell you that my number is on the first card, okay? I'll give you a second to look at the numbers there. My number is not on the second card. Okay. It is on the first card. All right. Now, if I look at these 2 cards, I see that my number is there on the first card again, but it's not here on the second card. So again, I'm going to use my wavy line and cross this one out. Okay. So my number is on this first card, but it's not on the second card. And finally, if I look on these 2 cards, I see that my number is on both of these cards. Okay. So looking at these, I don't know if you could memorize all the numbers and do a comparison in your head very quickly, but I will go back and I will show you one more time that my number is on card number 1 here. It's not on the second card. It's on this third card, but not on the fourth card. And it is on the 5th and 6th cards. Okay, did you guess my number? Well, my number is the number 53. All right. And I can do this calculation, it is a calculation, without memorizing all of the numbers on the card. I don't really care what's on the card. I am only interested in one corner of the card. Okay. The way that this works is it's using binary math, so base 2 mathematics. Let's talk about this a little bit. Okay. When we think and exchange money, we use base 10 mathematics. So if we're talking about pennies and dimes and dollars and $10 and $100 bills. That's all based on base 10 mathematics. So 10 to the 0, if you remember back to your elementary school days, that gives you a 1. And 10 to the 1 is a 10. That's the tens column. 10 squared is 100. 10 cubed, 10 to the 3 is 1,000. To the 4 is 10,000. And to the 5, 100,000. So my number was 53, and I'm going to represent this in base 10 mathematics. It's 5 tens and 3 ones, right? 53. Okay. And that's how we're used to seeing it. Now, a computer thinks using base 2 mathematics. We talk about bits, and a bit can be on or off, a 1 or a 0. 1 or a 0 on or off. So if you remember that little circuit, the circuit is either closed or open. So this all translates to the same thing. We talk about ones and zeros on and off for bits, and that's base 2 binary mathematics. Okay. And that's how a computer thinks. All right, so here, if we want to represent the number 53, what do we have to do? So 2 to the 0 is the ones column, 2 to the 1 is the twos column, 2 to the 2 is the fours column, 2 to the 3 is the eights column, 2 to the 4 is 16, and 2 to the 5 is 32. Now, getting to our exercise, we had 6 cards, right? So you see here 6 columns. I've gone out on purpose from 2 to the 0 to 2 to the 5th, so 2 to 5. And if you add up all of these numbers, 32, 16, 8, 4, 2, and 1, guess what? What do you come up with? Let's see, 32 and 16 is 48, and with 8 is 56. Let me try that again. 48 and 8, 56, and 4 is 60, and 2, 62, and 1 is 63. And guess what? I asked the student to pick a number between 1 and 63. Why? Because that's all that will fit in my model here, unless I go to another card that contains 2 to the 6th, right? But for the purposes of this exercise, we had 6 cards. And what we did is we took all the numbers from 1 to 63, and we developed the bit pattern for that number. So of course, for the number 1, it's going to be 0, 0, 0, 0, 0, 1. And for the number 2, it would be 0, 0, 0, 0. And the bit would be on, it would be a 1 in the twos column, and 0 in the 2 to the 0 column. Okay, you follow me? Now, if we want to represent the number 3, we would have 0, 0, 0, 0, 1, and 1. 1 in the 2 to the 1 column and 1 in the 2 to the 0 column, because you have a 2 plus a 1 is equal to 3. And finally, to represent my magic number, which was 53, we're going to have a 1 in the 32 column, a 1 in the 16 column, 0 in the 8 column, 1 in the 4 column, 0 in the 2 column, and 1 in the ones column. Okay, so if I add up 32, 16, 4, and 1, I will get the number 53. Okay, that will be my sum. Okay. Now, the way that the magic trick works is for every number between 1 and 63, we're going to place that number on the corresponding card where the bit is turned on, where it's a 1. and not a 0. Okay. It will be off on the 0 cards. So if you remember, as I was going through those 6 cards, it was on the first card. It was not on the second card. It was on the third card. It was not on the fourth card. And it was on the 5th card and the 6th card. And then as the person doing the magic trick, all you have to do with the 6 cards is look at the cards that are not crossed off and add the numbers in the corner. Let me go back. Okay. Here's the trick. You see here we have the 1s column. Here's the 2s column. Okay. Here's 2 squared. Here's 2 to the 3. 2 to the 4th. And 2 to the 5th power. Okay. So in the magic trick, if I was doing this in class and I came to a student that had this 1 card crossed off, I would take a 1 because that one was not crossed. I would add 4. I would not add an 8. I would add 16. And I would add 32. And magically, I would tell the student that their number was 53. Okay. So there you go. That's how it works. I hope that wasn't too confusing. But if you can think like a computer, think in 1s and 0s in bits that are on or off, then you know how that CPU works now. And everything that comes through the CPU is represented as these little circuits. And that's why when we talk about computer chips, we talk about how many circuits are on that little tiny chip. And the more circuits that are on there, the more data that can be handled. And also we use 1s and 0s for storing information too, so we can have more memory. Okay. How about writing a digital magic program? Let's write a program. And I used a fictitious programming language. I just kind of made up my own, roughly based on Pascal. But this is how it would work if you are writing a program. Now, if you're going to learn a language such as C or Pascal or even Python, then you can go ahead and use this as an example and write this program in that programming language. And that will be a fun exercise for you. But what we're going to do up front, we're going to identify some variables. Okay, we're going to tell the computer that we're going to have 6 variables. And the only options that can be stored in these variables is yes, no, or a blank. Okay. And then we're going to have an integer, a whole number, and that's going to be our magic number. And what we're going to do at the beginning of the program is we're going to set all of those variables to blank. Not yes or no, but just blank. And then we're going to set our magic number to 0. Okay. And then we're going to display that first card on the screen that had all those numbers with 1 in the corner. Okay. And we're going to ask the user on the screen, is your number on this card? And the person's going to answer yes or no. And those are the only 2 choices. If they try to type an X, it's not going to accept it. Okay, and then we're going to store that answer to the first variable. And then we're going to put a conditional statement here. If the person answers yes, then we're going to add 1 to the magic number. Okay, now there's a number of different ways, and I told you that before. This is the beauty of programming. You can accomplish the same task using different logic. Okay, so instead of adding as we go along, we could show all 6 cards and ask the user to say yes or no on all 6 cards and store those yeses and nos. And then we could, at the end, calculate the number. But I'm calculating it as I go along. So different ways to accomplish the same thing. All right, let's go on to the next step. So then we're going to display card number 2. We're going to say, is your number on this card on the screen? And the person's going to answer yes or no. And then we're going to store that answer to A2. And then if A2 is equal to yes, then we're going to add 2 to the magic number. And we're going to repeat this for all 6 cards. And when we get to the 6th card, if they say yes, then we're going to add 32 to the magic number. If they say no on any one of the cards, then we're going to skip. We're not going to add anything to the magic number. So at the end, we should have their magic number. And that would be the end of the program. So a little fun exercise. If you understand how we did the magic, then you can go ahead and, as you learn your programming language, you can actually write this little program and have people guess a number in their head and go through and answer the 6 questions on the 6 cards. And then you can have the computer guess their number. And that'll be your little digital magic program. All right. So lots of fun and an interesting exercise. And actually it has some value in that it can teach students how a computer thinks and really make kind of real in their minds this concept of circuits and bits being either on or off, ones and zeros. All right. So that is our exercise, and I hope this was fun and interesting. If you did find it interesting and fun, then please like the video and subscribe to my channel, and I will thank you for that. And in the meantime, stay safe, stay healthy, look after the health of others. I'll continue to work on more episodes, and I hope to see you next time. Take care.